Hi teacher, today we're going to talk about redox reactions that are a balancing method where we can observe the transfer of electrons between substances. In this balancing method, there will always be one element that is reduced and one element that is oxidized. The redox reaction in cadmium sulfide plus iodine plus hydrochloric acid equal to cadmium chloride plus hydrochloric acid plus sulfur. The first thing we need to do is to establish the oxidation state of each element. There are some important exceptions to remember. If an element is in free state, then the oxidation number will be 0. In a middle hydride, hydrogen has an oxidation state of -2, and in a peroxide, oxygen has an oxidation state of -1. In this case, the oxidation states are cadmium +2, sulfur -2, iodine 0, hydrogen +1, chlorine -1, and in the product, cadmium +2, chlorine -1, hydrogen +1, iodine -1, and sulfur 0. Next, we observe which elements change their oxidation state from reactants to products. We can see that the sulfur goes from -2 in the reactant to 0 in the product. So we put it here. And then we can see that the iodine goes from 0 in the reactant to -1 in the product. These elements will be part of the half reactions that help us identify which element is oxidized and which one is reduced. Once the half reactions are written, we first balance sulfur in the first half reaction, so that there are 2 sulfur atoms on each side. Then we do the same process with iodine in the second half reaction. We have to calculate the electrons that are transferred. In the first half reaction, we subtract -4, -0, that gives us a result of -4 electrons. And in the second half reaction, we subtract -0, -2, that gives us +2 electrons. Now that we have the results, we can identify which element is reduced and which element is oxidized. Here we can notice that the sulfur lost electrons, so the sulfur is the reducing agent because it increases its oxidation number. And then in the iodine, we can see that the number of electrons is increased, so it gains electrons, and it is our oxidizing agent and decreases its oxidation number. To make the number of electrons equal in both of the half reactions, we have to multiply the second half reaction by 2, so both of them have 4 electrons. As a final step, we balance the original equation using the values obtained from the half reactions, resulting in 2 iodine atoms in the reactants and 4 iodine atoms in the product. We have to make sure that after comparing the numbers of atoms on both sides, all of the elements are equal, so that the redox balancing is alright. As we can see here, the equation was balanced by adjusting the stoichiometric coefficients we got changing the chemical formulas using the redox half reaction method. Using the values obtained from the half reactions, the coefficients of the compounds containing sulfur, iodine, hydrogen, and chloride were adjusted so that each element ends up with the same number of atoms, as we can see here. So here we can accomplish the law of conservation of matter. Thank you.